In last class, we have discussed regarding force voltage analogous and also force current analogous. We have discussed, right? Today we shall discuss, and also we have discussed one problem on that. We shall discuss more problems. Okay, we shall solve the more problems on that force voltage analogy and force current analogy, and also rotational system and also translation system. They have given question like this: construct mathematical model for the mechanical system shown in figure, then draw electrical equivalent circuit based on force voltage analogy. That is force voltage analogy they have given. They have given the mechanical system. Okay, they have given the mechanical system. We need to draw the mathematical model, and also we need to draw what? Finally, electrical equivalent circuit. Okay. So for X1, how many connections are there? So K1 is connected, F of T is connected, M1 is connected, and also B1 is connected. And for X2, B2 is connected, M2 is connected, B1 is connected, and also K2 is connected. You can observe here between M1 and M2, B2 is there. Okay, this B2 connection is there. One end is connected for M1, another end is connected for M2. But B1 is connected, one end it is connected for M1 and M2, and another side it is connected. B1 is connected for both, and again it is connected for ground also. So here between X1 and X2, you will get only the thing is B2. Okay. So for X1, F of T, K1, M1, B1, and between X1 and X2, B2. Okay, and for X2, K2, M2, and B1. Okay. Now, how many equations you'll get? Two equations. Okay, two equations you'll get. So first equation, F of T is equal to M1 d square x1 divided by dt square plus B1 dx1 divided by dt plus k1 into x1 plus b2 into x1 minus dx1 minus x2 divided by dt. Now we have written this equation for x1. Okay. Now we should write equation for x2. For whether for x2 any force is connected? No. So what we should write? 0. So 0 is equal to B2. B2 is connected. B2 into dx2 minus x1 divided by dt plus for mass what we will write? M2 d square x2 divided by dt square plus B1 dx2 divided by dt plus K2 into x2. This is the two equations we have written by seeing the mathematical model. Now, what they have asked? They have asked the force voltage analogy. Now, you apply the force voltage analogy. M is replaced by what? L. And B is replaced by resistance. And K is replaced by 1 by C. And again, X is replaced by what? Again, X is replaced by integration of I into dt. Okay, integration of I into dt. And dx is replaced by dx by dt is replaced by I, and d square x divided by dt square is replaced by di by dt. If you cannot remember these all things, okay, so first you need to remember force is converted to voltage, m is that is mass is replaced by inductance, and friction is replaced by resistance, and the spring is replaced by what? 1 by C, that is capacitance. Okay, and here you need to remember that dx by dt or x tends to q. Okay, x tends to q. Dx by dt is nothing but I. That if you integrate this one dx by dt, you will get x is nothing but integration of I into dt. If you differentiate this equation dx by dt, so d square x divided by dt square, that will become di by dt. So you remember this one, okay? Remember this one. V of t, that is f of t is replaced by v of t, because they have said force voltage in ending only it is there. Force is replaced by voltage, v of t, that is equals to m is replaced by what? L 1 di by dt. Okay, this is di1 divided by dt plus r1 into i1 plus 1 divided by c1 integration of I1 into dt plus R2 in I1 minus I2, that is B2 is replaced by what? R. So B2 is nothing but R2 and dx1 minus x2 is there. So what we have written? I1 minus I2. Next equation, B2 is replaced by R2, I2 minus I1 plus M2 is replaced by L2, di by dt plus R1, because B1 is there. B1 is replaced by R1 and dx2 divided by dt, that is written as I2 plus again K2 is replaced by 1 by C. Okay, so 1 by C2 and x2 is replaced by integration of I2 into dt. Now there are two equations. One thing you need to observe is for two loops, this is a force voltage analogy. So for two loops, one element is connected. What is that? Resistance. You can observe in the equation, it is I1 minus I2 and here it is I2 minus I1. So by seeing the equation only we can say R2 is connected for both. We should consider for both the loops, for loop 1 and also for the loop 2. Okay, so for loop 1 and also for the loop 2, this is a loop 1, this is a loop 2. So for I1, when you write I1 equation, V of t, L1, R1 and C1, R2 is considered. R2 is considered the I1 minus I2 we will write. When you write the equation for loop 2, we will write I2 minus I1, that is for R2, right? So this is a loop analysis. First loop, what are the elements? L1, R1, C1. For C1, what you should write? 1 divided by K. K1, because K1 is replaced by 1 divided by C. Okay, K is replaced by 1 divided by C. So we will write here C. We will write in bracket 1 divided by K. Okay. Similarly, here also. This is a second problem what we have discussed on force voltage analogy. Next problem is draw the electrical network based on what? Based on torque current analogy. This is rotational. Okay, torque. Give all the performance equation for the figure. So what they have given? Theta 1, theta 2, theta 3. They have given displacement, 3 displacement. So how many equations you will get? 3 equations you will get. And they have given J1, J2, J3 and B1, B2, B3. Here for theta 1 only T of t is connected and J1 is connected. Theta 1. Okay. For theta 1, J1, T of t, B1. For theta 2, K1, J2 and B2. Okay. First theta 1. First theta 1. Okay. For theta 1, T of t we should write, J1 we should write and B1. Okay. For theta 2, K1, J2 and B2. Okay. So between theta 1 and theta 2 there is a K1. Between theta 1 and theta 2 there is a K1. And between theta 2 and theta 3, between theta 2 and theta 3 there is a K2. Okay. J2 is not considered like that. Okay, we will not consider between the displacement. Already we have discussed why it is not displaced, why we will not consider between the displacement. Okay, I think you can remember that. So for theta 2, 1, 2, 3, 4 connection. Finally, for theta 3, K2 is connected and J3 and finally B3. Okay, you can mark here like this, reference or ground it is. So what we can write here, no mass can be between the two nodes. That means theta 2 or theta 3. No mass, or it may be a inertia. We cannot place there. Why? Because there cannot be a change in force as mass cannot store a potential energy. We have discussed already in the important for problems. Okay, important points for problems. Mass or we can say inertia, we cannot connect it between two nodes. You may ask that between theta 2 and theta 3 there is a J2 and K2, but we will not consider this. This J2 cannot be considered between theta 2 and theta 3. This is a node. Okay, this theta 2 and theta 3 is a node. We cannot connect a inertia or mass between two nodes. Okay, it is only connected for the one node. So it is connected for the theta 2. Now write down the first equation which is related to the theta 1. So for theta 1, what are the connections you will get? T of T, that is like what we will write, force is equal to, like that only, torque is equal to, okay, T of T is equal to J1 d square theta 1 divided by dt square plus, instead of mass here inertia is there. That's it. Okay, so J1 d square theta 1 divided by dt square plus B1, what you will write, d theta 1 divided by dt plus K1. For K1, what you will write? Theta 1 minus theta 2, because it is in between two nodes, that is theta 1 and theta 2. Next equation we should write for theta 2. What are the elements connected? K1, J2, B2 and K2. Okay. So 0 is equal to, there is no torque is connected for theta 2. So 0 is equal to K1 theta 2 minus theta 1 plus J2 d square theta 2 divided by dt square plus B2 d theta 2 divided by dt plus K2 theta 2 minus theta 3. Okay, so theta 2 minus theta 3. When we are writing for this equation, so first you should consider theta 2 minus theta 3. And for this K1 theta 2 minus theta 1, because we are writing for the second. Okay, next we are writing for this. Okay, we are writing for this theta 3. Okay, so there is no torque, 0 is equal to K2. So for K2, what you should write? We are writing with respect to theta 3. So K2 into theta 3 minus theta 2 plus J3 d square theta 3 divided by dt square plus B3 d theta 3 divided by dt. Torque current analogy they have asked. So mass or inertia is replaced by C, capacitance, B is replaced by 1 by R, K is replaced by 1 by L, d theta divided by dt is replaced by V, and theta is replaced by integration of V into theta, and d square theta divided by dt square is replaced by dV by dt, and torque is replaced by current. It is in heading only. Okay, so now what you should remember is mass is replaced by capacitance and V is replaced by what? 1 by R, and K is replaced by what? 1 by L, and here d theta divided by dt is replaced by V. after writing this, you need to apply for these three equations. Okay, you need to apply for these equations. Instead of t, we will write I, and instead of j1, we will write c1, and d square theta 1 divided by dt square can be written as what? dv by dt, and b1 is replaced by 1 by r1. d theta 1 divided by dt can be replaced by v. So k1 is replaced by 1 by L1 integration of V into V1 minus V2 into dt. Okay. Here the similarity is K. K is nothing but what? Spring. Okay. K is spring. So it is similar to L. Okay. Inductance. We can remember like this. Okay. Spring also will be like this, and inductance also we will indicate like this. So we can remember in torque current analogy, K is nothing but 1 divided by L, and the friction is here, B is nothing but 1 divided by R. After replacing, you need to draw the electrical circuit V1, V2. This is V2, V3. Here, same as it is. Instead of K1, what we have written here? 1 by L. So, L1. This is K2. Instead of K2, we will write L2. That's it. Same mathematical model what you have drawn. Okay. Same mathematical model you should draw. Instead of T, what you will indicate? I. Okay. And instead of J, what you will indicate? Instead of mass or instead of J, what we have written? C. C1. Okay. Similar we need to draw. And instead of B, here B1 is there. So R1 should be there. Okay. Here R1. In bracket you should write 1 divided by B1, because here B is replaced by 1 by R. Similarly, K is replaced by 1 by L. So L1, L2 you write in bracket 1 divided by K1, 1 divided by K2. So for V2 also here, instead of J2, C2, instead of J3, C3. Okay. Instead of J3, it is C3. And similarly, instead of B2 and instead of B3. Okay. In next class, we shall discuss with the other problems.